When you are solving inequalities, just like when you're solving equations, sometimes there's a special solution, either all real numbers or no solution. Just like when solving an equation, the special solution case occurs when you end up with a constant on both sides of the inequality. We had a pretty simple rule for determining the special solution for an equation. Same constant was all real numbers, different constant, no solution. But we don't have a simple rule like that when solving inequalities. When solving inequalities, you need to look at the inequality statement that results. And if it's true, let's highlight this. If it's true, then the solution is all real numbers. If it's false, then the solution is that there is no solution. This will make more sense as we look at examples. First example, 3 times x plus 1 is greater than or equal to 3x plus 5. First, we use the distributive property. 3 times x is 3x, plus 3 times 1 is 3. 3x plus 3 is greater than or equal to 3x plus 5. Next, we subtract 3x from both sides. And we end up with a constant on either side of the inequality. 3 is greater than or equal to 5. If we were solving an equation, we would see two different constants and we would right away just say, no solution. When solving an inequality, we have to first think, is 3 greater than or equal to 5? Is 3 greater than or equal to 5? No. No, it's not. Since it is not, the solution is no solution. There is no value of x that you can multiply by 3 and then add 3, and end up with a bigger value than multiplying that same x by 3 and then adding 5. That's not going to be bigger than the right-hand side. So no solution. Let's try the next example, which has the same expressions but a different inequality statement or symbol. So 3 times x plus 3 times 1. 3x plus 3 is less than 3x plus 5. So same variable terms, same constants, same first step, subtracting 3x, and then I have 3 is less than 5. I can't just say no solution because I have different constants. I have to think, is 3 less than 5? Is 3 less than 5? Well, yes, 3 is less than 5. That means that my solution is all real numbers. All real numbers. So if I think about this mystery number x, I multiply it by 3 and add 3. Multiply it by 3 and add 5. It's always going to be the case that that left-hand side is less than the right-hand side. Adding 3 is going to have a lower value than when I added 5. No matter what the value of x is, that statement will be true, all real numbers. Moving on, example 3. 2x plus 1 is greater than or equal to, combining like terms, negative x plus 3x, 2x plus 1. Subtracting 2x from both sides, I end up with the same constant on either side of my inequality, 1 greater than or equal to 1. If I were solving an equation, I would see the same constant on each side, and I would automatically say all real numbers. With an inequality, I have to think, is 1 greater than or equal to 1? Well, it's not greater than 1, but is it equal to 1? Is 1 equal to 1? Yes. Yes, it is. That's a true statement. So this is an all real numbers special solution. Final case. Same expression on the left and right hand side. Different inequality symbol. Now I'm looking at a greater than. So is 2x plus 1 greater than 2x plus 1? I'm going to subtract 2x from both sides and I get 1 is greater than 1. My question to myself is 1 greater than 1? Is 1 greater than 1? No. 1 is not greater than 1. Since 1 is not greater than 1, this is the no solution case. In fact, I have the same expression on the left and right hand side, so the left hand side is not going to be greater than the right hand side, no matter what I plug in for x. To sum it all up, the special solution possibilities are the same for inequalities and equations. We can have an all real number special solution or no solution. Special solutions occur when there's a constant on each side of the inequality. What's different is I can't just memorize a rule. I need to look at my inequality statement with the two constants and think if it's true. If it's true, my special solution is all real numbers. If it's not true, no solution.